Hello, everybody. My name is Robert Douglas, and it's time for this week's edition of Deploy Friday. We call it Deploy Friday because we at Platform.sh think that Friday is the very best day of the week to deploy that code that you're working on right now. So go ahead, push commit, push it up to the cloud, and sit back and relax. It's Friday, and enjoy the show we've got today. The show we've got today is going to focus on OpenStack. Now, we recently had some members of the Open Infrastructure Foundation, formerly the OpenStack Foundation, and this episode is actually a continuation of our exploration of OpenStack as an enormously vital piece of open source software in the context of running your own cloud infrastructure. And with me today, I have guests who work with OpenStack as a foundation of their business. And I'm going to let them introduce themselves, but I'm really excited to hear the value that OpenStack is bringing to businesses and medical institutions and science institutions around the globe in this episode. So let's start with Dr. Jens Krüger. Jens, go ahead. Who are you? Where are you? And what organization are you with?
Yeah, hello everybody. My name is Jens Krüger. I'm head of the High Performance and Cloud Computing Group at the Compute Center of the University of Tübingen, southwest of Germany, on the other side of the Black Forest. Tübingen is one of the older, well-established universities in Germany with a strong focus on life sciences and medical sciences, among other things. And we are a little bit specialized in that area, providing compute, storage, and research data management for these communities.
Thank you. Awesome. Just give us a brief, so you're a customer of Sardina Systems, from which Kenneth Tan and Mihaela are part of, right?
Exactly. We are operating a couple of clouds, and they run on FishOS, Sardina's main product. And yeah, actually they are running, they are working, and people are using them. But I guess we talk about more details later.
Great. All right, let's move on to let's move on to Kenneth Tan. Who are you? Where are you? And what? Tell me about Sardina Systems a little bit.
Hi everyone. My name is Kenneth Tan. I'm one of the founders of Sardina Systems. We are a software company developing a cloud platform building on OpenStack, Kubernetes, and Ceph. Since founding the company in 20, we've grown over time, building the platform, focusing on operations tools, targeting private clouds. So,
okay, great. We're going to get into that in much more detail in a second, but I want Mihaela to also introduce herself, please.
Thank you. Hi, everyone. I'm Mihaela Constantinescu. I am responsible for marketing activities within Sardina Systems team. I have joined the company almost 5 years ago, and I must confess that I'm really proud of what we managed to build in this period, with ups and downs, of course, but especially going through the coronavirus times. Thanks to the great team that we have now with Sardina Systems, we managed to be the #1 choice for efficient private cloud management.
Awesome.
And I'm based in Romania.
Thank you. And it broke up for just a second, but you are the CMO of the company, right? The Chief Marketing Officer.
Yes, I'm the marketing director of the company.
Fantastic. Okay, let's get into the case study, the first one that Jens has brought us. So I was told that we are going to talk about a website called denbi.de. What is that?
Yeah, that stands for Deutsches Netzwerk Bioinformatik, or German Network for Bioinformatics.
Okay.
That is a federated research project environment with dozens of partners all over Germany. And part of this broader consortium is the so-called Dendi cloud. We
Dendi cloud.
have now 8 different sites where hardware is operated. In Bielefeld, Gießen, at the Charité in Berlin, at the DKFZ in Heidelberg, Freiburg, and also Tübingen. And all sites are operated individually, but we have a common framework, a common policy, a common authentication and authorization framework based on Elixir AAI, and also common project management for the applicants.
Okay, give me a broad picture of the need that this consortium serves. What problems are you addressing in the world?
So there are plenty of scientists, ranging from plant scientists interested in the descendants of certain crops and how to breed them to become more resistant to drought or stuff like that. On the one end of the spectrum, and on the other end of the spectrum, we have biomedical research, and these days COVID research, assembling virus genomes, but also looking on patient data, on probabilities to get really sick and who's prone, who's not prone. That are projects that are run by our scientists, our customers in the academic sector that are using our resources.
Okay. Would you give us the story of how you came to work with Kenneth and Mihaela and kind of what they do, what they bring to this consortium and the project?
Yeah, well, everybody who ever tried to install a computer at home on small scale knows how tedious that can be. And when we are talking about installations of hundreds of server machines with GPUs, without GPUs, integrating storage, establishing user management, I mean, that's our business. We know how to do that well for classical HPC systems, but for clouds, things are a little bit different. And therefore we got in touch with Sardina Systems, especially Ken and Mihaela, and agreed pretty quickly that we give it a try. And it was now, I don't know, 4 years ago, I guess.
Indeed.
Roughly.
Yeah.
Yeah, quite some time. And it worked out extremely well. I mean, the product, FishOS, is basically a nice phrasing for service and implementation help, if I may call it like that. Please correct me, Ken, if I'm drifting off. But I have to make a little detour. I mean, we are a university that is a public institution, and we are not really flexible in hiring people for short-term projects, building up such a cloud and things like that. And in that context, Sardina Systems came in extremely handy. A lot of knowledge and a lot of service when it came to configuring OpenStack services, creating proper concepts, where to place them, how to create high availability setups, load balancing, and things like that. I mean, it's all open source, OpenStack, but still to build up the knowledge to operate that in a safe and resilient manner isn't so easy and takes quite some time. And there we profited a lot from Sardina Systems.
Thank you. And I understand that Sardina Systems offer the FishOS is the product name, but that involves managing the OpenStack software with potential add-ons for managing Kubernetes and Ceph, which is storage, CEPH. Do you have all of those?
Currently, we only have the OpenStack service, if you like to phrase it like that. Just in these days, we are expecting the delivery of storage hardware, and we are going to build up a Ceph cluster for the German Human Genome Phenome Archive. That is one of the national research infrastructure projects that just started last autumn. And that Ceph installation is designated as long-term storage for sensible patient data. So not really an archive, but yeah, we have all the challenges there. We need a tight integration with the cloud. We have the GDPR rules, and of course, we want to do that properly. And yeah, I'm looking forward for the next weeks, how things will evolve on that side.
Well, great. Thank you. That gives us a broad overview of what's going on. Let's come back to that story along the way. I'd like to dive in a little bit more to the importance of focusing on OpenStack as the core of a whole company's product. So I think, Ken, this is really a question for you. When you founded this company, Sardina Systems, and you chose OpenStack, what were the things that you were looking for? What drove you to that decision? What are the qualities of the software that encouraged you to bet the farm on, that?
So before we formed the company in 2014, we actually did work in around the cloud platform arena, going back to 2011, 2012. So when you look at the market, so to speak, the open source world at the time, there were a number of candidates, number of projects that were building open source cloud platforms, but it was very quickly that we realized that the velocity of development in OpenStack was tremendous, and we therefore started in 2014, betting the farm, as you put it, building the company on OpenStack, and there is now.
Oh, okay, great. That was a very concise answer, and but also precise, which I appreciated. And we're getting a little bit feedback that the audio is inconsistent. I hope that that's not for everybody. So let's take a step back up. Mihaela, maybe you could put on your marketing hat for us. How do you describe your company and the product to people, the elevator pitch? Let's make sure that we really understood, what Sardina Systems does.
So first of all, I would say that I would like to mention, in fact, that we are an open infrastructure company, which means that FishOS, our FishOS product, is a distribution of OpenStack, fully recognized by the Open Infrastructure Foundation, formerly known as OpenStack Foundation. And if I have to put it like in a short, just to make it a very attractive pitch, FishOS is the product for any enterprise looking to accelerate innovation, to enable an efficient and flexible private cloud platform.
So focused on private clouds. So let's talk about private clouds. Who has private clouds? Obviously, research organizations like the University of Tübingen and the consortium around that. Who else has private clouds?
We can look into telecommunication, and there are plenty of big telecommunication companies, and we even have a user in Israel, for example, is one of the biggest telco provider in Israel. Then we can look into healthcare, finance, hosting, HPC, government.
So a lot of people have private clouds. Banks,
generally
they've got private clouds.
Generally, people who need things private.
I'm coming to appreciate your talent for succinct answers, Kenneth. That's great. Yes. Okay, that's a great.
Private and secure also. Not only private, but also very secure.
Private and secure. Okay. And Jens, you mentioned that when you were looking to build this cloud out, that one of the bottlenecks was finding the right people on a short-term basis. And that's kind of the trigger that you had for finding Sardina Systems. I mean, what was the problem space that led you to look outside of your own expertise for managing this?
Basically, there's a complexity of OpenStack services.
Okay. Is it really that hard? Tell me about it.
Yeah, the learning curve is pretty steep. I mean, when you're standing on the top, it's easy, but to get there on your own, that takes time and effort, especially time. And when we started the Dendi cloud in Tübingen, yeah, it should go online as soon as possible. And to prepare for that, during that time, we had 2 computer science master students put on that topic, find out what Nova is good for, what is a Cinder volume, deploy that, have a look, explain how it works, how shall we set it up. And yeah, these 2 guys were smart, put a lot of effort into it, but that was maybe a fraction of 20% or something like that compared to the level we are operating now on with the help of Sardina.
Okay. And it sounds like the project started at Tübingen and maybe was isolated at Tübingen, but it's since grown. Is that right? You mentioned all 8 other data centers attached to research institutions that are part of the system. How did that grow?
To be clear about that, the other sites are operating independently of each other. So some of the sites are also using Sardina Systems. Some do it on their own. Some have other support from other companies. So that's all a little bit individual.
Okay. Is there chatter between you guys saying, hey, go Sardina or anything like that? Yeah.
Yeah, I mean, to give an example, the colleagues from Gießen, I mean, after they saw the experience from us in Tübingen, maybe a year or 2 later, they also opted for Sardina. And how shall I put that? The colleagues over there are very knowledgeable and critical, and that they made such a decision is really a positive sign.
Okay, I'd say so. I would like to get more into the problem space of managing OpenStack. We've really only painted a very broad picture. Maybe, Ken, this is a question for you again. If I've never set up an OpenStack, can you talk me through what I would be facing if I wanted to do that for myself?
Sure. So in the early days of OpenStack, the challenge of deploying OpenStack certainly wasn't as easy as it is today. We recall, to deploy a system, you got to figure out how do each of the components relate to each other, understand that, and the thousands of configuration options, how do they relate? And sure, the code is open source. Theoretically, one could deploy it. And theoretically, Linux kernel is also open source. But how many of us actually run a Linux instance that is entirely built ourselves? Very few of us do that. And so we rely on a distribution to make that happen. And so in the OpenStack space, it's not that much different. There is the open source part, and we then turn into a distribution that is easier to deploy, easier to operate. Now, in relation to operation, once you deploy a system, you are then having to live with it. How do you live with the system? There are the log management tools for a start. Where are the monitoring tools? None of that's integrated with OpenStack. You could integrate them. Sure, that takes time and effort. Next release of OpenStack, the APIs may have changed. You're back to square one. And this is just in relation to the simpler functionalities around log management and monitoring. And as before, you go into some more advanced functionalities and as well as some of the functionalities that service providers need, such as usage accounting and billing, backup, so on and so forth. And then 6 months after you deploy the system, as I mentioned, OpenStack comes up with a new release. For the users, it's fantastic new innovation, fantastically new capabilities. But for the operators, they are fantastically new headaches.
And Jens is nodding to confirm. So you must have at least witnessed or experienced some of those headaches. And those are the kinds of headaches that Sardina Systems help alleviate, I take it?
Yeah, in short, they provide an environment and support for rolling update with theoretically 0 downtimes and practically something very close to that. So that saves a lot of headaches.
Okay, that's good to hear.
I have especially, sorry to interrupt, especially because whenever you do an upgrade, you need to do it N+1. You cannot skip upgrades.
Oh, it has to go sequential. Like you can't go 4, 5, 7. You've got to go 4, 5, 6, 7, whether you want 6 or not.
Exactly. Yes. So
okay.
Life is even harder.
That makes sense. That makes sense. So what are the prerequisites if I'm a potential customer for Sardina Systems and I think I want your services? What questions do you ask me to qualify me as a customer?
So once we address the question of scale, understand why do you want a private cloud? What are your drivers for private cloud? In other
privacy
words,
and security. I learned that already.
Correct. Whether privacy, security are amongst the reasons. And another driver is cost. So I can't go into the specifics of various operators, but we know of cases where certain operators are able to run positive margin if they were to charge prices of 1% of public cloud operators.
Oh, you mean Amazon's gouging us?
Not saying that.
Sounds like it. Sounds like it's never mind. Okay, so that means if I were to go get my own bare metal, and I do everything right, and I do it at the right scale, and I go for Sardina Systems and OpenStack, that I could basically have my own private cloud at really small fractions of the cost of if I were going to Azure or Google Compute Cloud.
Correct.
Wow. But you didn't mention cost savings as one of the reasons for wanting a private cloud. It sounds like that's one of the compelling reasons.
That's one of the reasons, but also we have a client which, when they did an analysis, they found that the full fat service versus a bare bones service. With full fat service, they could operate it at under a third of public cloud, and that's people cost, everything included.
That's very impressive. Okay. Yeah, now I know what I'm going to do with the room full of servers I've got next door. All right.
We can talk after.
Yeah, exactly. And I also want to talk to Jens afterwards about that, that chance I have of dying from a horrible disease that he mentioned. I was going to get your phone number after that one.
Yeah, well, I'm the hoster of hardware here and not the scientist. I don't have that hat on
right?
today.
I mean, you can go in and get the data, right? I'm just kidding. I know you can't. Good. So I would like to just back up a small bit and sing the praises of OpenStack from the point of view of Platform.sh a little bit. Usually the show, we don't talk about Platform.sh so much, but I wanted to say kind of the thought process that brought me to Sardina Systems when I was looking around the internet for experts in OpenStack who could come and talk about it and give some light to this amazing software that's enabling so many incredible projects like the DENBI project, the Dendi project, Dendi project. For us, we focused on OpenStack as simply a way to guarantee interoperability. And I think this is one of the very large selling points of open source in general, but OpenStack in particular, in that it's the way that software for cloud infrastructure management becomes interoperable. It's kind of like the pivotal, center point from which all of the spokes in the wheel come out, in my view of the cloud infrastructure world. So we focused on that because at Platform.sh, where we run a platform as a service, which allows you to basically throw your code, your application code into the cloud and just expect that it runs. We were able to do partnerships with 2 public clouds and actually make a private cloud. And I just wanted to, with wide eyes and a lot of admiration for the software, name these cases because they're so incredibly empowering to us as a business. For example, we were able to offer a public cloud pass for OVH, which is one of the larger hosters, cloud hosters in France and throughout Europe and in fact the world. And it's an offer that's just coming out now. Prior to that, we also offered public cloud PaaS services to enterprise-grade applications, primarily in France with Orange Business Services. And in that context, we even were able to offer a private cloud PaaS for a bank in France, which very much fits the definition of private and secure. So as you were saying all of these qualifiers for private cloud in particular, I was nodding my head, yes, oh yeah, that fits our case precisely. It was exactly the combination of having customer financial data and needing to manage security on your own and not being able to hand that off to an AWS or GCP that pushed that particular customer to the private cloud solution and enabled us to do business with them. And so I see OpenStack as this amazing enabler to bring together ecosystems of cloud infrastructure service providers like Sardina Systems and Platform.sh in a way that a public cloud can't, right? Because they're generally proprietary. There are lots of OpenStack public clouds, but there are also the GCPs and the Azures and the Amazons. And their goal is not necessarily to bring together this open ecosystem. Can you tell me more about, in that vein, can you tell me more about how you participate in the open infrastructure organization, because foundation? Because that was really interesting to me a few weeks ago to interview them about how they bring governance to the project. And now I would love to hear from the vendor point of view, what it's like to be a part of that.
Mihaela, do you want to answer this?
I will start, and then yes, you can complete. So from our point of view, we try to be as much as possible involved within the community. We get involved in all their events as well. We like the ecosystem that they are creating, and unfortunately, now that the events are not taking place anymore, that's a pity, because we don't have this environment to get in contact with all the people using OpenStack and all the users utilizing the software. But somehow we are still trying to get the benefits of the networking through different online events that they are doing their best to organize. And we recently became also an open infrastructure silver member of the foundation. So basically, we want to be in the foundation's environment, support the product as much as possible, and be in contact with the community.
Okay. Ken, did you want to add anything to that?
No, that's...
Okay. How about, I wanted to maybe go back to the point that you made about your system. It's FishOS. That also being an open source product, is that true?
So in OpenStack, in FishOS, we build on some open source OpenStack components. Some of the operations tools, these are not open source. These are our proprietary IP. So okay. It's a mix of both worlds.
And do you find opportunities to participate in the open source community directly with code? Is that a challenge? How do you make those decisions?
So we do contribute some code upstream, particularly on the tool side of things. And when we look at the development of open source, for Sardina, we tend to work with the developers and helping developers, enabling direction, providing input, and we've done that in a number of instances, including the firewall as a service component in OpenStack.
Did I understand firewall as a service?
Yeah.
Okay. Not familiar with that, but it
that's just yet another building block within the OpenStack farm of building blocks.
And how about at the university level, Jens? Is there a strong mandate in Germany to adopt open source and open protocols, or do you have basically your free choice to get things done however you want, even if it's to have Oracle come in and set up camp?
Yeah, I have to say it depends. When you're talking about scientific research, the funding agencies becoming more and more strict that the results have to be open and fair. So scientific data, including application, source code, and everything, when that happens within a scientific context. The other side, I'm working at a compute center. Of course, we need to operate things. And that also means, to buy in knowledge, to buy in software, and sometimes that's proprietary. That's just a fact like in every other company. So always depends. I see myself a little bit at the border between these two worlds. Therefore, I'm always trying to push my scientists to use open source software applications they can look into and understand and see what they are doing. That's part of good scientific practice. But it always depends a little bit on the discipline and on the community, how widespread this spirit already is.
Okay. So I was curious when you mentioned that you're investing right now in a Ceph storage layer. We had discussed Ceph a little bit before the call, before you got on with Ken and Mihaela, because that's a common component also in Platform.sh that enables some of the very specific capabilities that we offer, particularly on being able to snapshot a running application and make a copy of it into a development environment so that a developer has realistic data and realistic services to develop against. And we tie that to Git branches, and it's pretty cool. But that's really based on the capabilities of Ceph. So I just wanted to make a banner on that. So if you're watching and you can't acoustically parse what I'm saying, Ceph, and you're Googling for Ceph, but you're not finding it, it's there. It's ceph.io. What is the Dendi going to do with their Ceph cluster? What are the goals that you have?
Well, to provide storage, the very basic punchline. And the things we are going to install and set up are specifically designated for storing sensible data in the sense of patient clinical data, genomic data from volunteers that needs to be well protected, and that needs to be secure. Secure in the sense against data loss and disaster cases on the hardware. Because when we get, for example, a sample or the genetic information from a sample from a cancer patient, how sad it may be, but that guy might have passed away sometime after he got cancer. And if we suddenly, after 10 years, lose that data due to some failing hard disk, that would really be a pity because we can't go back and ask him for another sample. So that has to be secure, resilient, and well protected. And at the same time, we need a lot of capacity. This genomic data I'm talking about is huge. So easily several dozen gigabytes per individual sample, per individuum in such data sets. So
that's all CATGs, just like several dozen gigabytes of CATGs, or am I not understanding this well?
A human genome that is a couple of gigabytes, depending on how you represent that.
Okay.
And that sums up, we're aiming at several thousand, tens of thousand data sets. So overall, we will have a couple of petabytes. And the whole design is that we put the Ceph storage, in fact, we anticipate to create two Ceph storages at two different sites and have some geo-redundancy and replication between these two Ceph clusters. And like that, we hope to have all the security and durability we are looking for.
Fantastic. And what does Sardina Systems bring to the operation of that? What's kind of the process involved in setting that up and maintaining it? Do I call you and say, okay, the servers are all plugged in, go?
Yeah, that is a perfect description of what I'm doing. Ken, okay. Here's the hardware, good luck.
And I come back to Jens and say, Jens, here it is.
What's the password? That's the next question.
Yeah.
No, but in all seriousness, what goes into that?
So the process is broadly that hardware is there, and we catalog the hardware, and then from there on, we feed the essentially the list of nodes into our deployer, and we hit run.
It's that easy?
And, yep. This is why we invested in the deployment tools and automation tools. And at the end of that, we have a working system that we then deliver back to the client. Here it is, done.
And what's a typical use case where you bring value to the operations of a Ceph cluster, for example? Are there certain cases that come up which would be hard to handle or analyze that you bring, like, a flashlight into the darkness?
So recently we have a client that they are a service provider, fairly prominent in their home country. They had a problem with one of the they had some problem which they saw the symptom being storage being kind of slow, but exactly what's the problem? No idea. The smart data from all the disks. So now, where's the problem?
Could you repeat that last bit? I missed it. The smart data what?
So smart data was showing it's all fine. The disks, the hardware were all fine. So with that, where's the problem? We see this being that storage is slow. So how do we figure out what's wrong?
And Sardina Systems were able to help with that because of the tooling that you have.
Correct. So we used our tooling to identify that particular disk that was at fault, showing higher latency. And once we've identified that disk, we could then disable that disk. And once that disk was disabled, performance returned.
Okay, well, that makes sense. I mean, and from what I know about Ceph is a redundant storage mechanism. So if I throw a file or some data into it, then it's being put onto many copies, as many as needed to guarantee redundancy. And the as data comes in and is deleted, then Ceph is constantly rebalancing. So it sounds like maybe Ceph was trying to talk to that disk, and there were timeouts that were being hit, but somehow the monitoring wasn't catching that. That sounds weird. That sounds like a bug in Ceph.
Right. And perhaps to add a little bit of color to it, the service provider has amongst their customers their national orchestra. So if the system doesn't perform well, the national orchestra has a problem.
That cuts deep to my own heart, since I'm a trained orchestral musician. With all respect for the cancer patients, I think this case is very compelling, the orchestra case. No, all joking aside, that's pretty amazing that even something as non-technical as an orchestra is still in the end dependent on these extraordinarily complex technologies to bring things about in the digital age. Who would have thought? Very cool. Jens, do you have any plans to expand into the Kubernetes product that Sardina Systems also offer? Maybe I'm asking a question I shouldn't be asking publicly.
Well, I mean, we can be open about that. Kubernetes as buzzword, as topic, pops out once in a while among my users. That's not a big surprise. Everybody's talking about that. But after a second and third look, in many cases, the use cases don't really fit. So these guys often are more happy with the classical batch queue or just a VM. So it always depends. We are currently working on one project where we create, we could call that a science gateway based on multiple microservices. And there, it's the first time in the last years for me that I'm seriously thinking about putting that on a Kubernetes cluster to balance everything and so on. But we have to see what the future brings there.
Okay, that makes sense. We actually have a question from the audience. I'm going to pop that up here. Coming back to the Ceph question, are there alternatives to Ceph? And that's a question that I don't know the answer to, so I'm going to defer to Ken.
So certainly there are alternatives to Ceph. With OpenStack, we can plug into a broad range of storage backends. So, and typically you're looking at storage that presents themselves with the iSCSI interface, or indeed we could also talk to traditional NFS.
Network file system, yes.
Yep. Good old NFS.
Good old NFS, but that lacks a lot of the. I mean, that's great for just storage, but correct me if I'm wrong. But doesn't NFS lack a lot of the redundancy and self-healing and rebalancing?
That's right. That's right. That's right. That's
and it doesn't have copy on write and snapshot.
That's right.
Either,
so it's a little. It shows up being a little bit slower, but in terms of functionality, from the OpenStack point of view, it works.
It's like comparing a floppy disk to iCloud.
Indeed.
Okay, good. And by the way, if there are more questions from the audience who might be live right now, please feel free to ask them in the comments. We do get those. And if you're listening to this on the podcast or at a later time, then write to us on an email or Twitter, and we'll still try and get your questions answered, that is. So I don't have any direct questions, but what am I missing here? What would you like to tell the audience about OpenStack or your experience that we haven't covered?
Yeah, maybe the flexibility. We were talking about privacy and security quite a lot, but using a cloud in general is way more flexible than any other compute solution like classical HPC or supercomputing or stuff like that. There's a lot of power behind that, but often it lacks the flexibility. And for
how do you characterize that flexibility? What are some examples of the flexibility you mean?
I mean, we were talking about the Dendi cloud in Tübingen. We have another cloud. It's called Machine Learning Cloud. The name says it all. Tübingen is quite strong on AI and machine learning. And these guys usually have a workstation with a big GPU to create their models, develop code and everything. But then they need to train that to do some parameter studies. And the modus operandi we have with these guys that they have a VM with a strong GPU, all based on OpenStack and FishOS for development. And then we have a virtual queue, again, with plenty of GPUs where they can submit their workload. And all under the same hood, all with the same credentials, all pointing on the same storage. That's extremely convenient and efficient.
And the storage in this case is predominantly to store the large data sets that are being modeled on top of. Is that right?
Yes.
So it's like the storage there. It's mostly read only. Is that those sets? I mean, I'd mostly be reading that. That's how it can be shared between like a development environment and a production queue, right? Like I develop on a micro microcosm of the data, but then when I really want to train the model, I put it into the big system and let it run. Is that how it works?
Pretty much, yes. The training data sets can be made available read-only almost everywhere. Then you have the intermediate data, of course, and then the result data, and we can spread and separate and do how we like.
Okay, and all of that's because you run your own private cloud on OpenStack.
Yes, and I mean, in theory, that also would be possible to deploy and run something like that on a public cloud. But just to get the environment up and to have the, how shall I call that, service nodes up and running all the time, the costs would go through the roof.
Okay, fantastic. What else am I missing? Ken, talk about your company a little bit more. What part of it have we not covered?
So, I mean, if you look at, so today we've talked about private cloud usage of FishOS. If you look at a cloud, whether it's private or public, from an operator's perspective, is it really that much different? The answer is no. It isn't that much different. The principal difference between a public cloud and a private cloud is in the fact that in a public cloud, the service consumer and the operator do not belong to the same organization. Whereas in a private cloud, they are. And so when you then look at it from the operator's perspective, could you use the same platform that is used to run a private cloud to provide a public cloud? The answer is yes.
That makes sense. I mean, as I mentioned with Orange Business Systems and OVH, it's exactly that interoperability of the stack that allowed us to be partners with those.
Indeed.
And since I came back to case studies from Platform.sh, I wanted to ask Mihaela, are there other anecdotal case studies from your customer base that you wanted to share that would show the strength of OpenStack in enabling great solutions, whatever industry?
Well, we have plenty of them, but most of them cannot be mentioned as from reasons that we spoke before. I can name a few. For example, we have telcos in Israel, one of the biggest telco provider in Israel. We have healthcare in Australia, and the system there, FishOS system, is helping the company to support the modern medicine and intensive care sector. We have hosting providers, banks. We even had a bank case, which again cannot be mentioned due to security and information. What else? I don't know. Am I missing anything else?
And are the benefits for these customers generally similar to what Jens has presented, or is there diversity in their use cases?
I would say, in a broad stroke, yes, they are very much similar, perhaps in slightly different configurations sometimes. So in one particular case, the client, they run FishOS as the platform for their product development, and they have several clouds within the enterprise. FishOS systems are used not just for day-to-day development, but also for the entire CI/CD process. So their product is built on OpenStack, deployed on OpenStack, and so the FishOS system sees continuous create, delete, a whole bunch of parts of their product. That particular product, their VM count, their component counts are quite large. Sometimes they're creating several hundred VMs in a go. And so these sorts of high throughput create, test, delete, usual in CI/CD processes.
Okay, fantastic. And one last question, because everybody likes numbers, big numbers. What are some of the, you must be able to see, you know, in your dashboards, what are some of the larger numbers of like machines that you manage for any particular client? You don't have to say who it is or even where they are, but like what's big in your world?
I would say, so first off, we don't necessarily get into the details of what happens in a custom site, but at a certain customer site, we're looking at several 100,000 VMs.
Several 100,000 VMs.
Yeah.
Okay, that's a lot. How about for your cloud, Jens? Do you have a sense of, can you give us a sense of the scale of it in any metric that's meaningful or not confidential?
No, I mean, academia, that's all public. That's easy here. But yeah, well, to compare to that number, I think today we had something like 20,000 VMs deployed, not necessarily running. So we
Okay.
are relatively small on the scale of a tier 3 cluster or something like that.
Okay. I still think 20,000 VMs is fairly respectable. Back in the day when you used to do web development by spinning up like VMware or something like that on your computer, then I had like 7 or 8 VMs running on my computer at one point, and it was dead. It was like, man, that was the end of it. So like scaling to 20,000 is already pretty respectable. All right, good. Final comments, anybody? Anything, hi mom, anything that you want to add before we say goodbye for the week? All right, then I'll let you off the hook. Thank you so much, Mihaela, Ken, Jens. That was really informative and exciting to me to hear how you guys are working together in the sake of science and academia, making the world a better place, solving real practical problems, and that we all have this common interface together through OpenStack, which is clearly one of the best governed and well-positioned open source projects overall that I know of, and I only have respect for the people involved with that. So thanks for joining me today and talking about that. And for all of you out there, see you next week for another edition of Deploy Friday. Don't forget to get push to the cloud now. It's Friday, and then go have your drink. All right, bye everybody.
Thank you, Robert. Thanks for having us.
Thank you, Robert. Thank you.